In 7.2, we are going to be working on verifying trig identities. So these are things where it gives you some sort of trig expression that's equal to something else, and you have to show that it's true. Personally, I like these better than the simplifying ones that we did in 7.1 because you know when you're done. Like when you get the two sides equal to each other, that's it. You've done the work. So what I've got for you in this box are some strategies that you can use. These are things that might help you. These just take practice, knowing what things you can do with these and kind of tricks that you can do. But these are some suggestions. You always want to work with one side of the equation at a time. Usually you want to start with a more complicated side and get it simplified to the other side. But you can work on both sides of the equation. So if you work on the left-hand side for a little bit and kind of get stuck, we'll move to the right-hand side and see what you can do there. Some things that might help would be factoring, or if you have two fractions, adding them together, or squaring something, or if you have a binomial in the denominator, creating a monomial or something like that. So those are some things, and you'll see examples of those throughout the lesson. Look for opportunities to use your fundamental identities, so your Pythagorean identities, switching like tangents and cotangents, using the reciprocal identities, those type of things. Sines and cosines pair well together, secants and tangents, cosecants and cotangents. So those all pair well together with your Pythagorean identities. Something that works if you don't know what else to do is you could try just converting everything to sines and cosines. Sometimes that helps. You just have to try something. Okay, even if you don't even know where to start, if you just try one thing, it might be a wrong attempt. It might make things worse, but you can see something. You might be able to see something in it. Like, oh, I did this wrong. It's not getting me anywhere, but I have an idea of something I could do differently. And then the most important thing that I want to stress is these look like equations because it says something equals something. But we don't know that these two sides of the equation are equal. That's what we're trying to prove. So we can't add or subtract something from both sides of the equation. We can't multiply both sides of the equation by 2 or divide both sides of the equation by 2 or anything like that. Whatever's on the left-hand side stays on the left-hand side, same thing with the right-hand side. So those are our general guidelines, and we are going to just jump in with number 1. We want to verify that sine squared theta plus cosine squared theta over cosine squared theta secant squared theta is actually 1. So using the suggestions we just talked about, we're going to work with the left-hand side. It's the more complicated side. So the first thing that I see is our favorite trig identity, our favorite Pythagorean identity, sine squared plus cosine squared equals 1. So I'm going to replace that with 1 over cosine squared theta secant squared theta. It's also important as you do these problems that you're showing each of your steps. Someone else should be able to follow along and say, oh, okay, I see what they did there, I see what they did there. It's not just good enough that you do it, somebody else needs to be able to follow your work. Okay, so let's take a look at this. Secant squared, I could use the reciprocal identity there. I'm going to leave cosine squared theta. Secant is 1 over cosine, so secant squared is going to be 1 over cosine squared. And of course now, cosine on top, cosine on the bottom, those are going to cancel each other out, and we are left with 1 equals 1. So we have verified the identity. Let's move on to number 2. All right, we want to show that 2 cosecant squared beta is equal to 1 over 1 minus cosine beta plus 1 over 1 plus cosine beta. I'm going to start on the right-hand side this time because it looks a little more complicated. One of the guidelines we suggested was maybe combining fractions, so let's try that. I'm going to use the picnic table method that we talked about the other day, but if you want to get common denominators, you can. So I'm going to multiply these, and I get 1 plus cosine beta. I'm going to multiply these, and I get 1 minus cosine beta. And then on the bottom, I'm going to multiply those. 1 minus cosine beta, 1 plus cosine beta. All right, I haven't done anything with the other side, so we'll just leave that alone. Okay, let's see. In the numerator, cosine beta and negative cosine beta are going to cancel out. So I'm left with a 2 on top. In the denominator, I'm going to FOIL this out here and here. So I get 1 plus cosine beta minus cosine beta minus cosine squared beta. And positive cosine beta, negative cosine beta, those are going to cancel out. So I have 2 over 1 minus cosine squared beta. Let's see, I'm running out of space here. That's okay. Okay, this side, I haven't changed anything about it. Oops, except I wrote things poorly. Okay, I think I can keep going on the right-hand side. This should make me think of my favorite Pythagorean identity, that sine squared plus cosine squared equals 1. And so if I subtract cosine from both sides of this, I get sine squared beta equals 1 minus cosine squared beta. So I can replace the denominator here with 2 over sine squared beta. And this is 2 cosecant squared beta. And now I could go one of two ways. I could keep going on the right-hand side, or I could change the left-hand side if I wanted. Actually, let's back up a step. You may recognize that cosecant is the same thing as 1 over sine, so cosecant squared would be 1 over sine squared. The 2 is going to stay on top, and now I've gotten it. Okay, now I could have changed the right-hand side into 2 cosecant squared beta, but I chose to change the left-hand side. That's okay, as long as we work until they're equal. We will come back in the next video and finish up that last problem.